Hello, hi dear students. Welcome to my channel, Maths with Panitra. In this video, we are going to discuss about the equation of tangent to the ellipse, the equation of normal to the ellipse, parametric point and eccentric angle, and also equation of tangent and normal at parametric point, and some notations we are going to discuss. This is the fourth video of ellipse, continuing video for the previous video. So let us have a discussion. Some notations we will discuss, notations regarding ellipse. Here S represent the equation of ellipse, x square by a square plus y square by b square minus 1. This is the value of S. S means equation of ellipse. And S1, the meaning of the notation of S1 is, in place of x square, xx1 by a square, in place of y square, yy1 by b square minus 1. Suppose if you want to write S2, in the above S1, wherever 1 is there, you have to replace with 2. So it will become xx2 by a square plus yy2 by b square is equal to minus 1. If you want to write S11, to get S11, in S1, wherever x and y is there, you have to write x1, y1. So it will becomes x1 by a square plus y1 by b square minus 1. That also can be written as S11 equal to x1 square by a square plus y1 square by b square minus 1. This is about S11. This is about S1. And next S12 also we are going to discuss. S12 means in S2, wherever x comma y is there, you have to replace with x1 y1, you will get S12. See here, x1 x2 by a square plus y1 y2 divided by b square minus 1. These are the notations in ellipse. Regarding ellipse we discussed. After that, the equation of tangent. The equation of tangent, very simple way, just a revision class it is. After that I will enter into the problems. Equation of tangent at p of x1 comma y1. And equation of normal at p of x1 comma y1 to the ellipse, S is equal to 0, to the ellipse, S is equal to 0. So here first draw the rough figure to the equation of tangent we are calculating. So this is the ellipse figure. So let p of x1 comma y1 be any point. You draw a line which touches at p as well, ellipse. So this equation is called the equation of tangent. The equation of tangent at S, at p of x1 comma y1 to the ellipse S is equal to 0 is S1 equal to 0. This is the equation of tangent. That is, what is S1 notation here? That's what you can write it here. Xx1 by a square plus yy1 by b square minus 1 equal to 0. This is the equation of ellipse. Equation of tangent to the ellipse at the point x1 y1, and the equation of normal Normal means what? The line which is perpendicular at the point P of x1 comma y1 to the ellipse is called at the point for the tangent itself. This is the equation of ellipse. This is P of x1 y1. At this point, this is the tangent equation. For the tangent equation, normal is always perpendicular. So this is normal equation at P of x1 comma y1. So this equation, the equation of normal at P of x1 comma y1 to the ellipse x is equal to 0 is a square x by x1 minus b square y by y1 is equal to a square minus b square. This is the formula for calculating the equation of ellipse, equation of normal at P of x1 comma y1 to the equation of ellipse. This is equation of tangent. This is equation of normal. After knowing of equation of normal and tangent, one important point is there. X is equal to a cos theta and y is equal to b sin theta. These equations are called parametric equations. These equations are called parametric equations. Parametric equations to the ellipse, where theta is called parameter, not only parameter, it is called eccentric angle. Eccentric angle. The theta value lies between 0 is less than or equal to theta is less than 2 pi. You remember that? X is equal to a cos theta, y is equal to b sin theta are called parametric equations of the ellipse. That means these are satisfying given equation of ellipse s is equal to 0. S is equal to 0 means x square by a square plus y square by b square equal to 1. That's what the equation of ellipse. That equation is satisfied by these equations, x equal to a cos theta, y equal to b sin theta. After that, one important point regarding this, x comma y equal to x in terms of theta, y in terms of theta. So a cos theta, b sin theta. Whenever x comma y in terms of theta, if you write, this point is called parametric point, which is simply denoted by p of theta. This is called parametric point. Simply denoted by p of theta. At p of theta, what is equation of tangent? At p of theta, what is equation of normal? See here, in place of x1, y1, substitute a cos theta, b sin theta. This equation will become, in place of x1, a cos theta. So a get cancelled. You will get x by a cos theta plus y by b sin theta minus 1 equal to 0. This is also equation of tangent at p of theta. Equation of tangent at p of theta to the ellipse. S is equal to 0. In the same way, wherever x1, y1 is there, you have to replace with a cos theta, b sin theta. So it will becomes a cos theta, if you substitute, one of the a cancel. So ax by cos theta will come there. So this equation, here I will write it, equation of normal, based on the convenience. Ax by cos theta minus byy sin theta is equal to a square minus b square is called equation of normal. Equation of normal at p of theta to the ellipse s is equal to 0. This is equation of normal. I already said that. This is the ellipse figure. Some point here I am taking p of theta. This is the tangent equation. This is the normal equation. This is tangent. This is normal equation. To the ellipse s is equal to 0. This is equation of tangent at p of x1 y1, equation of normal at p of x1 y1, equation of tangent at p of theta, equation of normal at p of theta. Now we will discuss about the different points, and whenever the line touching the ellipse, then the point is called point of contact. If the line is y is equal to mx plus c, what is point of contact? If the line is touching the ellipse, what is the condition? This we are going to discuss now. Yeah. The next concept, observe carefully. Point of contact, tangent condition, that we are going to discuss. This is the equation of ellipse. Here let p of x1 comma y1 be any point. Suppose a line y is equal to mx plus c. Y is equal to mx plus c. Touching this line, touching this ellipse. So then p x1 y1 is called point of contact. This is called point of contact. That is called point of contact. So how to get that point of contact? If the line y is equal to mx plus c touching the ellipse at x1 comma y1, that means it is a tangent equation itself, no? At x1 y1, what is the tangent equation to the ellipse? S is equal to 0 be the ellipse. That means S1 equal to 0 tangent. X1 by a square plus y1 by b square minus 1 equal to 0. This is equation of tangent. Keep that equation number 1. Even y is equal to mx plus c is also touching that ellipse at the point x1 y1. So why I am taking this side? That equation is mx minus y plus c equal to 0. Equation number 2. Equation 1 and 2 represent the same lines. Represent the same lines. Whenever the lines are representing same, their x coefficients are in proportional, their y coefficients are in proportional, their constants also proportional. Here x coefficient is what? x1 by a square divided by, here x coefficient is m, equal to, here y coefficient is y1 by b square divided by, here y coefficient is minus 1, which is equal to, here constant is minus 1, here constant is c. So after that it will becomes x1 by a square m, denominator will become again denominator here, minus y1 by b square, minus I already wrote in the numerator, minus 1 by c. If you equate these two, you will get x1. If you equate these two, y1. So x1 is equal to a square m, we can take this sign, minus a square m by c. If we equate these two, minus minus get cancelled, y1 is equal to b square, we are taking this side, b square by c. So x1 y1 means what? Here point of contact now. So therefore the point of contact is minus a square m by c comma b square by c. If the line y is equal to mx plus c touches the ellipses x square by a square plus y square by b square equal to 1, Then the point of contact is minus a square m by c comma b square by c. Any line like this they will ask you. You can use the condition, point of contact. Next, what is the condition if the line touches? In the ellipse equation, x square by a square plus y square by b square equal to 1. In place of y, substitute mx plus c. So, x square by a square plus mx plus c whole square divided by b square equal to 1. After simplifying, you will get, whenever the line touching, here discriminant of the quadratic equation will come. Quadratic equation in terms of x will come. After that, the discriminant equal to 0. Then we get c square equal to a square m square plus b square. This is the condition. The line y is equal to mx plus c is to be tangent to the ellipse s is equal to 0. Then the condition is c square equal to a square m square plus b square. This is the condition. C square equal to a square m square plus b square. After knowing the condition, here I will mention that this is the condition that the line y is equal to mx plus c, the line y is equal to mx plus c is to be tangent to the ellipse, is to be tangent to the ellipse. S is equal to 0. Very important condition, dear students. Keep in mind and practice number of times. C square equal to a square m square plus b square. From that, if you want to see, if you remove square here, plus or minus root of a square m square plus b square. So this c value substitute in this equation. Therefore, the equation of tangent with slope m, equation of tangent with slope m to the ellipse, from an external point, p of x1 comma y1 is, wherever y and x is there, external point x1 y1 we mentioned means in place of y, y1. So y1 is equal to mx1 plus or minus in place of c a square m square plus b square. Now onwards you remember that this is the equation of tangent with slope m to the ellipse from an external point p of x1 y1. So the figure will come like this. This is the ellipse equation. Suppose some point we are taking there, p of x1 y1 here. This is one tangent. This is rough diagram I am drawing. This is another tangent. So if we observe carefully, from an external point to the ellipse, we have maximum 2 number of tangents. That is the reason here we are getting plus or minus 2 cases. After knowing the tangent equation, we will discuss about more important points regarding MSET and JEE. Suppose in place of y is equal to mx plus c, lx plus my plus n is there. This line is lx plus my plus n equal to 0 is to be tangent. Then the point of contact, the line lx plus my plus n is equal to 0 touches the ellipse equation, touches the ellipse, then the point of contact is minus LR square, LA square by N minus MB square by N. This is the point of contact x1, y1. Suppose this line touching the ellipse, then the condition. The line Lx plus My plus N is equal to 0 touches the ellipse equation. S is equal to 0. Then the condition is A square L square plus B square M square equal to N square. It is looking like C square equal to A square M square plus B square. So A square L square plus B square M square equal to N square is the condition. The line Lx plus My plus N is equal to 0 be the tangent to the ellipse. These two are very important conditions. If they will ask point of contact, if you apply the shortcut formula, you will get it. If they are asking to calculate some unknown value from the line, if this line is a tangent to the ellipse, by using this condition, you will get the unknown value. After that, direct or circle, I am going to discuss. The next concept. Here some point P of x1 comma y1 we are taking. This is the ellipse equation. We are taking some point there, P of x1 y1. Draw the two tangents from a point P. Here, from an external point P, we draw two tangents. That means the tangent at x1 comma y1 with slope m is y1 equal to mx1 plus or minus root of a square m square plus b square. That is, if we consider plus one equation of tangent, if we consider another equation of tangent. After that, mx1 we can take this side, mx1 we are taking this side. So y1 minus mx1 is equal to plus or minus root of a square m square plus b square. Squaring on both sides, a minus b whole square expansion, y1 square plus m square x1 square minus 2m x1 y1, and these values also I am taking this side. We will get it as minus a square m square minus b square equal to 0. From these two m square take common, m square into x1 square minus a square plus m into minus 2x1 y1 plus the rest of the terms y1 square minus b square. It is a quadratic equation. It is a quadratic equation. It is a quadratic equation in m. Then it has two roots m1 and m2 respectively. What are m1 and m2 means? Slope of first tangent, slope of second tangent. That's all. Sum of the slopes m1 plus m2 equal to minus b by a. So here already minus is there. So 2x1 y1 divided by a value is x1 square minus a square. And product of the slopes m1 m2 equal to c by a y1 square minus b square divided by x1 square minus a square. Why I am explaining is, sometimes they will give point and the equation of ellipse. They will ask to calculate sum of the slopes or product of the slopes. You have to use these concepts in the public examination, like any competitive exams. These two are very important. One is sum of the slopes or some of the roots also. This is product of the slopes. After getting these two important results, based on product of root slopes, we have one important result that is called director circle. What is meant by director circle? Suppose if we take one point here, from here I am drawing one tangent there. This is another tangent. If you consider another point here, here one tangent, here another tangent. Here is the point. The point of intersection of perpendicular tangents. These two are perpendicular. These two are perpendicular. The point of intersection. Suppose if we consider the point is here. This is a tangent equation. This is another tangent. The point of intersection of perpendicular tangents is called director circle to the ellipse. If you join like this, you will get one circle equation. This is called director circle. Director circle of the ellipse. What is the director equation of circle? Director circle of the ellipse. The point of intersection of perpendicular tangents to the ellipse is called director circle. These two tangents are perpendicular, like this it will be. So, the equation of director circle will be x square plus y square equal to a square plus b square. Sir, how you know that? According to the definition of director circle, the tangents are perpendicular. When the lines are perpendicular, what is the condition? The product of slopes equal to -1. Here product of the slopes we have. So since in the director circle, since tangents are perpendicular, m1 m2 equal to -1. m1 m2 value is this only, no? y1 square minus b square by x1 square minus a square is equal to -1. Cross multiply and we'll get it as y1 square minus b square equal to minus x1 square plus a square. So all minus x1 square we can take this side, minus b square we can take this side. Therefore we will get it as x1 square plus y1 square equal to a square plus b square. While writing the locus of the point P, you will get the equation of director circle. So therefore the locus of point P, the locus of point P is x square plus y square equal to a square plus b square. This equation is called director circle of the ellipse. So now onwards you remember that what is director circle to the equation of ellipse is x square plus y square equal to a square plus b square. This is very important, director circle. After that, auxiliary circle is also there. Auxiliary circle. What is meant by auxiliary circle? The circle which described on major axis of an ellipse as a diameter is called auxiliary circle. Observe the figure. This is an ellipse equation. Center A dash. The circle which described on major axis, A dash is called major axis. The circle which describes on major axis of an ellipse. Then this equation is called auxiliary circle. How to find out the equation of auxiliary circle? From here to CA means A units only, know, from here to here. Center is what? 0, 0. Center 0, 0, radius is A. So the equation of auxiliary circle x square plus y square equal to a square. This is the equation of auxiliary circle to the ellipse. If A is greater than B in the equation of ellipse x square by a square plus y square by b square equal to 1. When A is greater than B, this is the equation of ellipse. Suppose if A is less than B, the auxiliary circle equation is x square plus y square equal to b square. These two are very important. What is the auxiliary circle to the given equation of ellipse means? What is the auxiliary circle definition? What I told? The circle which describes on major axis of an ellipse as a diameter is called auxiliary circle. Diameter means A dash. A dash equal to what? 2A. Length of major axis. In that CA is half of the major axis. That means semi-major axis, which is equal to radius of the circle. So radius of the circle equal to R is equal to A. Center is 0, 0. Therefore, the equation of circle whose center is 0, 0 with radius A is x minus 0 whole square plus y minus 0 whole square equal to A square. So x square plus y square equal to A square. When A is greater than B, this is called auxiliary circle of the ellipse. When A is less than B, in place of A, B will come. Why? Because the circle will become like this. That is called the auxiliary circle related to A is less than B case. We will move to the next concept. Yeah, in this concept only, the angle between the two tangents is theta. The angle between two tangents at P of x1, y1 to the ellipse is theta. Then angle is tan theta equal to mod 2ab into root s11. I already given in the notations what is s11 divided by x1 square plus y1 square minus a square minus b square. This is the formula you have to remember. The angle between the two tangents from an external point x1, y1 to the ellipse. These are the two tangents. An angle between them is theta, then tan theta equal to 2ab divided into root of s11 by x1 square plus y1 square minus a square minus b square. That is regarding angle between the two tangents of the from the point x1, y1 to the ellipse. The next concept, the area of the ellipse. Ellipse equation is x square by a square plus y square by b square equal to 1. The area of ellipse. The area of an ellipse is pi AB. From here to here we know that is A units. From here to here it is also B units. One is semi-major axis, another one is semi-minor axis. So now onwards you remember a formula. The area of an ellipse is pi AB. After that, one more important point, especially they are asking regularly in the competitive exams, the maximum area of rectangle inscribed in ellipse, in an ellipse, s is equal to 0 is 2ab. Here 2ab. The maximum area of the rectangle inscribed in an ellipse s is equal to 0 is 2ab, and whose dimensions are L is equal to root 2a and breadth b equal to root 2b. So here that means the figure will come like this. The maximum area of rectangle inscribed, this is the rectangle inscribed in Here two important points are there in this. One is the maximum area is 2AB and whose dimensions are length L is equal to root 2A and B equal to root 2B. So maximum area of rectangle inscribed in the ellipse S equal to 0 is 2AB and whose dimensions, that means length and breadth, root 2A and root 2B. After completing of these two important concepts, one more important concept is there. So observe carefully. This is the ellipse figure. This is the focus. This is another focus. This is the tangent equation at the point. This is a tangent equation at any point of the ellipse. Tangent equation at the point, suppose P you are taking here. Some point P. From foci to tangents, draw the perpendiculars. This is one perpendicular D1. This is another perpendicular D2. Here, the product of perpendiculars or the product of perpendicular distances, the product of perpendiculars from foci to any of the tangent, any tangent, the product of perpendiculars from foci to any tangent is equals to B square if A is greater than B is equal to A square if A is less than B. Based on the condition, these two are very important. Separately I am writing. Yes, here suppose F1 is the foot of perpendicular, F2 is another foot of perpendicular. This first case I am writing here. SF1 into SF2 is equal to B square if A is greater than B. Similarly, second case, SF1 into SF2 is equal to A square if A is less than B. So these are the two important things you remember. The product of perpendiculars from foci to any tangent to the ellipse. These are very important in competitive exams. Regularly they are asking this one and this one and this one. This is well known. In the maximum minimum also we use this formula IAB. Even these two formulas also because the maximum area of rectangle inscribed in that. Let us have a discussion, some questions related to this one. Otherwise, in the coming video, we will discuss about these concepts and relative questions. Thank you all.